In this video, we are going to take a look at a clipper that consists of a trimmer head, a nose trimmer head, and a shaver head. We will also explore the working mechanism of all three heads. In order to properly explore the working mechanism of all three heads, we are going to take a look at each head separately. Same will be done for the body. But first, let's start with the body. To turn on the device, an AC power cord with the appropriate connector is inserted into the charging port, which then gets plugged into an AC wall socket. By turning on the wall socket, alternating current is supplied to the charging port. The current then travels through these two wires to the power board in the device. The power board is made up of several electrical components that all work to sufficiently step down the incoming alternating voltage, usually 110 volts or 220 volts, to about 5 volts or 6 volts. The power board also contains a rectifying circuit that converts AC current to DC current. This DC current is supplied to the two metal strips underneath the PCB board. When the battery is inserted, these strips come into contact with the battery's terminals, charging the battery. The PCB also has two DC current output points to supply power to an electric motor. The output point on the left has a solder point. Therefore, a wire is drawn from this end of the output point to the electric motor. But for the other output point, we have an electrical contact point. The contact point appears to end abruptly, with no wire connected to it. The second wire for the motor is, however, drawn from a separate contact point, isolated from the rest of the power board circuit. These two contact points must be bridged in order to get the DC current to the second red wire connected to the electric motor. In order to do that, we need some form of switch. The device makes use of a slider switch button, usually found on the upper half of the body. It consists of two legs that are able to snap into grooves or recesses. When the button is lowered, the legs pass through a slit in the upper half section. Underneath this is a slider piece with slits that enable it to snap over the legs on the switch button. A strip conductor with two legs gets mounted on the slider piece by means of two protrusions that hold it by friction. The switch button, when engaged, moves either forward or backward. But as it moves, the slider piece moves along with it, and so does the strip conductor. Notice that these two contact points are still separated. But as soon as the switch button is engaged, it pulls the slider along with it. The strip conductor also gets pulled along with it until its legs are over the two contact points. The strip serves as a conducting path that closes the circuit, and current flows through these wires to the electric motor. This current is what drives the electric motor. A drive cam is mounted on the motor shaft, and so it spins along the shaft. The drive cam has a protruding notch that is offset from the axis of the shaft. As the shaft rotates, the notch revolves about the shaft's axis. We can see here that the top half section has a protruded piece. The button half section has a similar protrusion as well. When the two halves are combined, they form some kind of neck for the body, with the drive cam sticking out of the neck. Now let's take a look at the first head, the trimmer head. An explosion of the trimmer head reveals its constituent elements, as shown here. Now let's walk through the process of how it all comes back together. Let's call this the top half section, and this the bottom half section. If these two leaf-like strips are lowered, they will go into the recess on the bottom half. A shaft goes into a slot on the top half, while the cam follower lever is mounted on the shaft. This allows the lever to swivel to the right and to the left. Another important part here is the quick release adapter. It has protrusions above and below it. As it gets lowered, the protrusion underneath it goes into a slot on the bottom half. The top half section, which now has the shaft and the cam follower lever, will then be lowered down so that the lever shaft neatly passes through a corresponding hole on the lower half. The protrusion above the adapter also sits in the slot on the top half. Next, two screws go in through screw holes on the bottom half and through the leaf strips all the way to be fastened to the top half, holding this portion together firmly. Now let's call this part the blade assembly mount. It has a notch that enables it to be guided into a slot on the bottom half, forming some kind of fulcrum. The rest of it swivels until the other two protrusions begin to push against the leaf-like strips, flexing the strips until they snap into place. Next, we have a tension spring that is moved to sit in a slot on the blade mount. The cam follower then gets attached to the tension spring through two mount holes. With the cam follower in place, the movable blade gets mounted on it. Next, the stationary blade is used to cap the assembly. But as the stationary blade gets mounted, it pushes against the movable blade. The movable blade then pushes against the cam follower, which in turn engages the tension spring. The tension in the spring ensures that the cam follower constantly pushes the movable blade towards the stationary blade. Finally, the screw holds the blade assembly to the blade mount. Now let's see how the head is mounted. To attach the trimmer head, the head is turned slightly in the clockwise direction to about 45 degrees. The quick release adapter that seats in the head has a number of notches that form a pattern. The notches have been highlighted for better easy observation. The pattern formed by these notches corresponds to the pattern formed by the recess found on the body's neck. By rotating the head, the quick release adapter assumes an orientation that would allow the neck of the body to pass through until the body flushes with the head. At this point, the head is rotated in the opposite direction until the notches on the quick release adapter snap into the recess on the body's neck. Let's get a better view of this. We can see the notches on the adapter as they move into the recess on the body's neck. This all happens while the mouthpiece sits in the head. To remove the head, the adapter will simply be turned in the other direction until the notches snap out of the recess, releasing the head. But let's keep it locked on. Now that the trimmer head is properly attached to the body, we can see the drive cam notch in between the groove on the cam follower lever. While the tip of the cam follower lever lies between the cam follower. By switching on the device, the electric motor spins the drive cam, and as it spins, the lever tries to keep the notch on the drive cam between the grooves. As a result, the lever gets deflected to the left and to the right. The lever, in turn, deflects the cam follower accordingly to the left and to the right. This reciprocal motion is transferred to the movable blade, which then cuts any hair strand caught between the blades. The tension spring ensures that the blade is instantly pulled back, which helps prevent the blade from becoming too loose, allowing for more effective trimming. The trimmer is then brought towards the hairline to cut hair. We can clearly see how the mechanisms inside all work to produce the reciprocating motion required. When the blade assembly advances into the hair enough, a number of hair strands will be caught in between the movable blade and the stationary blade. The cutting edge of every tooth is sharp, so with every stroke the movable blade makes to the side, it cuts the hair strands that get caught. In the second part of the video, we will look at how the nose trimmer head and the shaver head work. Thank you for watching. Please like and subscribe for more content.